I didn't record any of that, did I? Oh, darn, I said so many good things. Yeah, whoa, no. Unfortunately, well, okay. I addressed distance students. If I had a decent screen to look at, I'd have realized I wasn't recording. Okay. On the other hand, if I was functioning 100% today, I probably would have noticed. I probably would have recorded. And so I did a lot of stuff without recording, but this is all stuff we did on the quiz. Okay. So I'm not sure what to do about that. I want to take a lot of time out of class to repeat everything. 20 minutes of this. These problems without the solutions, this, and this were given as a quiz. People worked it out. What I tell distance students to do is, normally I'll have the quiz here and I'll show it to you, and then I'll work things. What you need to do is do the quiz honestly, so that I can see what you know and don't know. Because if you do it dishonest, like you just put these things into your calculator and don't do steps, I don't know if you're learning anything or not, and I can't help you. All I see is, oh, yeah, getting the right answers. Everything looks good. Okay. Well, what I want is something like this. I want it all written out and scanned and emailed to you. Okay. And do it without reference to anything else. Now, if you want to do it twice, once without reference to anything else, say, okay, here's what I did. Now I looked some stuff up and here's what I saw and here's how I can fix it. Okay, that's a very good thing to do. You're welcome to do that. Matter of fact, I'm really welcome to that. But so you want to work the quiz. You know, after the homework is due. This is on homework that's actually not due until after tomorrow. Yeah, we'll get into the details. One of them was a science. Everybody should have been able to do these. At least this. Okay. I thought I gave a really good explanation of this stuff. I don't know my class. I thought we did a good job. I'm going to go over it very quickly. Okay. What 7/3 mean? What will you guys do? Do it again. I'm going to do this in 5 minutes. Okay. 7/3 means you got a table full of small pieces. They're all cut into 3 pieces. Every one is cut into 3 pieces. 7/3, well, each piece is a third. So 7/3 means 7 of those pieces. 13/3 means 13 of those pieces. Well, how many pieces do you have? You have 7 plus 13, you have 20, right? So you got 20 pieces, and they're still thirds. So the rule is we add the numerators, don't change the denominator, and we get how many thirds we have. Okay, if you tried to add the denominator, you'd have 26. All of a sudden, your thirds that you had right there on your plate shrink down to sixths. Cut all the thirds in half and throw one of the halves away. Okay, it doesn't work. It doesn't make any sense. Okay, well, now we got 3/4 plus 5/8. Now we're adding fourths and eighths. What are we going to do about that? Well, if we multiply 4 by 2, we get 8. And then we'd have the same denominator. So we multiply the 4 by 2, but we can't just multiply the 4 by 2. That would change the fraction. We multiply by 2 over 2, which is like multiplying by 1. And we get this. And then plus 5/8. Why do we do this? Because when we multiply the numerators, we get 6. We multiply the denominators, we get 8. And our 3/4 is now 6/8. Okay. And now we can add 6/8 and 5/8. That just gives us 11/8. Okay. Now, a little more complex. We got 3/5 plus 4/3. There's nothing you can multiply by 5 to get 3. Nothing you can multiply by 3 to get 5. So can you not get a common denominator? Well, you can. If you multiply 5 by 3, you're going to get 15. And if you multiply over here, just 3 by 5, you're going to get 15, and you're going to have the same denominator. You can always multiply this denominator by this one and this one by this one and get a common denominator. You usually want to get a least common denominator because the numbers are easy. Okay. And there are other reasons that go into what we do with rational functions and pre-calculus. Okay. And that's way down the road for everybody in this course. We want to understand fractions. You have to understand it to learn some pretty essential things in pre-calculus. Because we start doing this with symbols in pre-calculus. Okay, so here we have it. So we do just what I said. You've got to multiply this 5 by 3, but you also have to multiply the numerator by 3, or your fraction changes its value. It changes its size. Okay, so when we do that, we get 9 over 15. 9 over 15 is the same as 3 over 5. If you can reduce 9/15 to 3/5. Okay. If you cut that pizza into 15 parts, you take 9 of them, you have exactly as much pizza as if you cut it into 5 parts and took 3 of them. You think about that, that's the essence of why we do this. If you just do it by good, because that's a rule, okay, well, you won't understand it as well, but it's still going to get you by here. Okay, and still helps build you toward where we need to go. It's better if you understand why we do these. So think about pizzas, unless you're really hungry and don't have a pizza. Okay, and then we do the same thing over here. We multiply the 3 by the 5. We got to also multiply the 4 by the 5. We get 20 15s. Then we can add 9 and 20. We got 9 15s. We got 20 15s, which gives us 29 15s. Not 29 over 15 plus 15, it's 29 over 15. Okay. Now, this example, there are a couple of ways you can add mixed numbers. The way I've seen people doing in the quiz today is, I think the open math, obviously, I think probably instruct people to do that. 4 1/5 means 4 plus a fifth. 5 4/5 means 5 plus 4/5. Okay, so this is the same as this. We can change the order of the addition and do 4 plus 5 and 1/5 plus 4/5. And that gives us 9 plus 5/5, which is 9 plus 1, which is 10. So that one comes out pretty easy. This one gets pretty long. I'm going to explain it kind of quickly. We got the 6 3/8 minus 2 3/4. Well, that's 6 plus 3/8 minus the 2 plus 3/4. We have to have parentheses around the 2 plus 3/4 because we're subtracting the whole 2 and 3/4. We've got to subtract the 2 and we've got to subtract the 3/4. Then we just use the distributive law to simplify this, minus 2 minus 3/4. Okay. And then we do the 6 minus 2 and the 3/8 minus 3/4. Okay. Now, 3/8 minus 3/4, using the same kind of steps we used up here, gives us negative 3/8. Okay, I did that in a couple of steps. You do want to write out all the steps to reinforce it until you're so sick of doing it and you know you don't have to. But don't ever underestimate how many times you got to rewrite the steps. Yeah, 4 minus 3/8, which we can write as 3 plus 8/8, 8/8 being 1, 4 is 3 plus 1, so this is 3 plus 1. And then minus 3/8. Okay, 8/8 minus 3/8 is 5/8, so we get 3 and 5/8. More? Well, maybe a simpler way to do this, but you really want to understand this. You really want to understand what's happening with the fractions. It makes you better able to think about other things, mathematics, and even outside of mathematics. Okay. We can do it like this. Multiply the 8 by the 6, you get 48, add 3, so this is 51/8. And the reason for that is, how many 8s are there in 6? You got 6 pieces, divide each of them up into 8 pieces. How many pieces do you have? You have 48. And then you have 3 more 8s. That gives you 51/8. Similarly, 2 3/4 gives you 11/4. There's a reason for the rule, but the rule is you multiply this with this and add this, and then put it over the denominator. Okay, so 51/8 minus 11/4. Well, we got to put that over common denominator, so we got to multiply this fraction by 2/2, giving us 22/8. So it's 51/8 minus 22/8, which is 29/8. Well, 28 goes into 29 3 times with 5 left over. So the 3 times gives us 3 pieces. Okay, and the 5 left over gives us 5/8 on the piece. So there we have it. Down here, I threw this in as kind of a wild card because we hadn't done this, but maybe we have. 2/3 times 5/8 minus 3/7, the quantity 5/8 minus 3/7. It's 2/3 times 5/8, there it is, minus 2/3 times 3/7. There's your distributive law. And then just multiply these out, you get 10/24 minus 6/21. I stopped there because I was out of room, but at this point you do a common denominator. Turns out in this case, you're going to multiply this by 8, you're going to multiply this by, I'm sorry, you're going to multiply this by 7, multiply this by 8. Your denominator is going to be 168, your numerator is going to be whatever it turns out to be when you do that. And in other words, you just do this the same way you do this, it's just the numbers are a little bigger and you got to think about these common numbers. Okay? So that's it. Okay, was that worth hearing twice? Yeah. They're being polite. Okay, saying yes. Hope it was. Okay, now here are 4 problems. Kind of give you a preview of the assignment that's going to be due the day after Labor Day. So I'm going to ask people to work these problems and then we'll talk about the solution. If you're a distance student and you happen to be using the videos, recommend that you do that. Okay, you don't need to send it to me or anything unless you have a question about it. But I recommend you stop and do that the same as the class is doing. All right, got this equation, x plus 5 equals 9. What are you going to do? Well, the way you're used to writing it out, it's a little less compact than the other way, but it works. You write out the equation minus 5 equals minus 5. Why would you do that? Because if you add this to this, you're going to have a 5 and a minus 5. And I think I saw somebody use a plus 5 here. Well, that was close. Right idea. But make sure that if you add this to this, you end up with just x. Now, I've written that out, x plus 0. I should line that up better, but I already messed it up. X plus 0 equals 4. I kind of want you to write that step because I want you to get used to thinking about every step. Of course, if you add 0 to any number, and x stands for a number, it just gives you x, and that gives you 4. Then you check it. If you take 4 and plug it back here, this gives you 4 plus 5 equals 9. And we know that's true, so we put a little check mark next to it. Understand what I just did? Replace x by 4 and check out that this is really true when x equals 4, because that's what it means to solve an equation. Okay, over here, 7x equals 28. Well, if I divide 7x by 7, I get x, don't I? Well, I can't just divide this side by 7 and not do anything to this side. If I don't divide this side by 7, the 2 sides aren't going to be equal anymore. I got 2 things. I got a pizza. Cut this pizza into 7 pieces, take one of the pieces, and then over here I got another piece. Well, that's maybe not a good example, but we have to do the same thing to both sides. Okay, so now x equals 4. And we can check that. Take this half out here. plug it in for X, it gives us the equation 7 times 4 equals 28. And if we know multiplication tables, if you use a calculator for numbers are bigger, we can verify it. 7 times 4 is 28, 28 equals 28, and we have the right solution. Okay, so I can't emphasize strongly enough that anytime you solve an equation, you check it. Okay, you check to make sure that that solution gives you an equality when you plug it into the equation. Okay, we got x over 3 equals 4. What am I going to do here? Well, I'm going to multiply this by 3, except I'm going to write it as 3 over 1 to make sure we understand that we're multiplying fractions. Okay. And I write it this way because too many people at this stage are unsure of what it means to multiply x over 3 by 3. Right, 3 is a fraction, 3 over 1. Okay, well, that gives us 3x over 3 equals, and yeah, this is a fraction. We're going to make that 4 over 1. It gives us 12 over 1 here. Well, 12 over 1 is 12. 3 divided by 3 is 1. That leaves us x, and there's our solution. That's a little more complicated. The thing I want to emphasize is the whole idea. You're confused about how to multiply a fraction by an integer. Write that integer as a fraction with the 1 in the denominator. Just plug this back in, and it gives us 12 over 3 equals 4. And we can divide 3 into 12 easily. Count the 12 by 3. It's 3, 6, 9, 12. That's 4. Okay. Now, this one is a little bit of a curveball, but how did we solve this? You notice that when we multiply both sides by 3, we ended up with no denominators. Okay. Over here, and this is important because you're not going to solve problems with variables in the denominator unless you know to do this. And also, anytime you have an equation with fractional expressions, find a common denominator for all those expressions, multiply everything in the fraction, both sides, using the distributive law, by that common denominator, and your denominator is going to disappear. So what looks kind of confusing becomes very easy. And well, what I'm going to do is I'm going to say, okay, x, I'll write x over 1 times 15 over x equals x over 1 times 3. I've just multiplied both sides by x. And actually, I probably ought to write my 3 as 3 over 1. Probably should have lined it up better. Should have thought that through a little better. But x times 15 gives us 15x. Denominator is x. X times 3 gives me 3x. Or 15 equals 3, because 15x over x is just 15. Equals 3x. Okay. So pretty simple step. Multiply out the x and do it correctly, and you get an equation with no denominators. It's really easy to solve. Okay, now we're out of time. I'll just put the center down there. Everybody should know what to do with this. It's just like this. Okay. And of course, Open Math is going to give you plenty of examples and videos. And you got the text. You should be reading the text part. If there's a text section that goes along with the Open Math, not every assignment has that, especially in these review assignments. Remember, we're reviewing elementary algebra for a few weeks, and then we're going to dive into intermediate algebra. Okay. So really need to nail this. And if you're having too much trouble with the elementary algebra, you might consider moving to the MDE 10 course. Okay, I'm not going to make you do that. I'll advise you if I think you need to. I've got to see more of your work. I got to see what happens when you get the assignments done and how quickly you pick things up. Okay. I want you to go the best place you can. In an MDE 10 course, you get this stuff, but it's spread out over the whole term instead of just 4 weeks. Okay. So if it turns out anybody needs that, and I'm talking as much to distance students as anybody in here, okay, just blanket. Okay. MDE 10 could be an option. If over the next couple of weeks, you're just having trouble getting the elementary algebra, okay? Because you got to build an elementary algebra. I think most people are going to be okay with that. It's too early to tell. So I wanted to mention that right now. Okay, didn't need to stop that. So have a great Labor Day weekend. And look forward to seeing you a week from today. Do some good work.